So thank you everyone for joining us this evening, and thank you to the friends, of course, of the Thomas Crane Public Library for making this event possible. And tonight we are very excited to welcome Mass Audubon expert Sean Kent for Maple Sugaring Winter Magic.
Thank you. Thank you so much.
Thank you so much for having me. I really appreciate it. It's really nice to come here. And like I said, I'm Sean Kent for Mass Audubon, and I work at Mass Audubon's Metro South region as the education manager, and my background is also as a field biologist. So if you've ever been to like the Trailside Museum in the Blue Hills, I manage that location. There's also an education center up at the top of Blue Hills in Chickataway Hill called the North Smith Education Center, where we have like retreats, overnight, stuff like that. So we're having about 300 Boston Public School 7th graders come out in the fall and the spring for an overnight field trip, hiking, nature journaling at team building. And then in Canton, where my office is the Museum of American Bird Art Education Center. That's about 125 acres with pottery and a really wonderful wildlife sanctuary. And then tonight, I'll be talking mostly about the maple sugar operation that we have with Moose Hill and Sharon, about 35 minutes away here, right off the 95. That's a little under 2,000 acres, and with the conservation land around there, it's well over like 2,300 acres. So it's one of the largest contiguous areas of conserved land in that part of the state. And then the fifth site that I work at and oversee is the Stony Brook Wildlife Sanctuary in Norfolk, which is a beautiful wetland with boardwalks that go through ponds and stuff like that. And I'm here tonight to talk about a little bit about the magic of like maple syrup and how that whole process works. And what I'd like to do too here as well, and it's why in the picture here it's not a photo of maple syrup bottle, you know, like this from Moose Hill. Right here, it's not a photo of the tree of like the sugaring operation. What we have here is, now this is a red maple tree, but it's very similar. This is a sugar maple. This is a red maple tree, not a sugar maple. But right there, you've got a warbler, and I took this picture just in a parking lot in Canton two falls ago. But I want to talk about how sugar maples also are a really important part of our New England forest ecosystem, and how that all kind of ties into sugar maple and how all that works. But first, you know, at Mass Audubon in Moose Hill right here, we have a large, you know, kind of educational sugar maple operation. And last weekend, we had our like kind of annual sugar maple festival event where people kind of got to see the whole operation. So I thought I'd show you a little bit about that, then talk a little bit more about the process and how these trees are really important just in New England and, you know, in Quincy in general right through here. So this is just a group of kids and their parents kind of learning more about sugar maples. Here, these two sugar maple trees right here, these are about 275 years old. And essentially, so they're going to be very long lived. You can see the buckets operating, you know, tapping right there. And then here is kind of a very simple process from one of our programs of how the trees get tapped. So you can see trying to drill right into the tree, tapping in. My one participant in this. And you can see where she was even drilling right here. Look at this little process. It's already even, the sap is already running out of it as it's going in. You know, her bucket was put up right there. She's looking in to see any tap in there. And then kind of there's the sugar maple bucket with the sap running out of it. And I'll talk about the entire process as we go along through the evening right here. But you know, in the sugar maple process, this is the sugar shack here. I'll go through the whole chemistry that's going on in here. But this is where the maple sap is being boiled down into the right concentration for maple sugar. Maple sap into maple syrup, and then if you did maple sugar right there. And you can kind of see all the steam, all the condensations of the program that was there just earlier this week. You can see all the steam coming up right there from the sap getting boiled off. It's a wood-fired system right through there, so they actually go through about 10 logs every, 10 minutes or so to boil all of this off running through there. So that's, again, upwards of 1,500 degrees right through there. You can see all the all the steam right there. So this is all water vapor. This is a picture I took last weekend right through here of the entire sugar shack with all the steam catching in there from all the maple sap that's being boiled down into maple sugar. And these are called, this is just called an evaporator, which I'll talk a little bit more later, but just kind of giving you the whole overview. And the whole goal here is to boil down the sap to a higher sugar concentration, so you end up getting your maple syrup, which you can see here and right here, you know, with the caramel color and everything. So you can see that. So, you know, a little bit of an overview just at Moose Hill, so you kind of have a basis for then what I'm going to talk about as we go through this in kind of more detail. And please feel free to hop in again, any questions or anything like that. But Moose Hill's sugar maple operation for Mass Audubon started in 1975. However, you know, the history of the site shows that the farmers in the 1800s were probably and almost certainly tapping the trees back in the 1800s. So the 250-year-old tree, and these are probably wedding presents for the Billings family, they're called George and Martha there. They were probably tapped as well in the 1800s. And there's about 400 tappable trees there because there was probably a farm-based operation there in different types of sugar bushes that I'll talk about. So 12 years ago, there was about 10 to 15 gallons of maple syrup produced, typically on average. Oh. In 2020, we had 76 gallons from over 250 taps, with 5,000 gallons collected. And I'll go through the ratios in a little bit there as well too. This year we're still finishing up, but well over 100 gallons of maple sap for 60 maple syrup for 6,500 gallons of sap. So by far the best year. And I'll go through why this year was so good. We have about 400 trees that we can tap at Moose Hill, and there's typically about half of them are tapped. And I want to talk about too the ways we collected through the bucket system that I just showed on the pictures, but then also a higher tech but very simple tubing system. And every year, you know, this was last week, and we have thousands of people that are visiting. And last weekend during the Sugar Maple Festival, for me, you can see this picture where there was a lot of people. We had about 750 people come through on 2 days for tours and everything. So it's like an hour and a half tour where you go, where you learn about the whole operation. You taste maple sap, you taste maple sugar, you taste maple syrup. You go to different stations. You see the sugar shack. It's a really, really nice experience that we do usually the second weekend in March every year, depending on the weather. Okay. So before I talk about the process of maple syrup and the tapping of the trees and how that actually works, I kind of want to give you a broader context of New England forest ecology and how this whole system works and why it's really, really important and how everything's happening. So here's a picture of kind of a typical kind of woodland, and this is at the Mass Audubon Sanctuary in Canton, where I work. This is a vernal pool, so a little woodland pond with down trees. In this picture, you can see, you know, red maples, there's sugar maples, there's pines, there's high bush blueberry tucked in there. You know, so why are trees important, especially sugar maples, because they're one of our dominant trees within the entire system. So I kind of want you to think about New England forest ecology and how these trees play a really important role. So there's things like the carbon and water cycle, and just very simply with the carbon and water cycle, so carbon, that's everything that you're seeing there is made out of carbon, so it's storing carbon, you know, through carbon dioxide, going through photosynthesis and storing that in the tree trunks. It's releasing carbon when the leaves are falling and decaying, when the tree trunks are falling and all through there. The water cycle, so it can store lots of water, it cleans lots of water, it moves it around. And what I really want to highlight is how important having many different types of trees, many different types of shrubs, from like blueberries to sweet pepper bush to serviceberry, all these different types of plants, how important this is. And then also the flowering plants, like the little wildflowers that grow in the woods. So how important this is into the entire way that our ecosystems can work in the right way, and how it can be really important for, you know, birds like this right here, this yellow-rumped warbler. And then if we look at services that it provides for, us, like the maple syrup, for example, it's really important for our lumber and our wood production, the maple syrup production, which I just talked about. But then if you think about, especially when you have like the really heavy rainstorms in the summer now, and the roads are flooding in Quincy, when you get all the rain and everything like that, these areas, especially if you like the forests, they can capture a lot of that water. If you think of an oak tree, or especially if they cut an oak tree down on a city street or something like that, that oak tree prevents 3,000 gallons of water from ever hitting the ground during a rainstorm, because it captures in the leaves and then it evaporates again. So it's really important for keeping water out of the streets, just so that, that you can see there, because those flooding events are getting more and more common. And then it's also cleaning a lot of that pollution that's coming off the roads. These trees, these plants can do a really important job with that. Think of the fall as well, with the fall colors, how beautiful that is, the nice transition through the seasons. So there's a lot of services that they provide, both for the ecosystem itself and the plants and animals that are there, but also for us. In Quincy and the greater Boston area, the forests are removing 7.5 to 10 million pounds of pollution every year. They're avoiding an incredible amount of stormwater runoff, saving tens of millions of dollars. This will become more and more important as these storms get more intense, and then they're storing a lot of that carbon. And you can really kind of take this to heart in Quincy with the marshes and everything there as well. A single acre of marsh is going to store up to 1 to 2 million gallons of water and hold that in there and make it flow slower, so it's not getting into the system as quickly. So that's just a little bit of a background there. So then if we look again, just kind of tying back into this diversity of trees and shrubs and understory plants, it's really important, especially at the beginning, in March, in April and May, for if you like having birds and other animals in the yards and around there, these are providing habitat, places for them to nest, places for them to hide, and, food. With this down log right here, and I bet people, I should, at the end, if you'd like to hear it, I'll play the song of the Carolina Wren, because this is going to be in Quincy. This is going to be all throughout the city. It does really well for you. This down wood right here is going to provide lots of food in terms of insects and other kind of animals for these birds to eat. It's just a really important, it's just really, really important. Here's a sugar maple grove in this picture right through here, just tying in the whole diversity and color and everything like that. But these robust understories, like in here, with the ferns that are going to be coming out, the small woodland plants, this is going to be wild raspberry here, the shrubs and the smaller trees, whether they're sugar maples here, sassafras, and even taller sugar maples here and here. These systems, as they're saying, can be really, really important for both us and also wildlife in our culture right now. So if you look back at the photograph that I showed earlier, what is kind of these roles? What do you see here? You see a lot of the downed wood that's coming in. This is going to melt and be in a little pond in the woods. You've got the dominant trees that I talked about, from the pines to the maples to the oaks. There's going to be a ton of cover on the ground, whether it's from leaves to smaller ferns and plants, and then the shrub section through here. Okay. If there were a lot of deer here too, with not any other animals to kind of control, this would all be open. Okay. This would all the deer would have eaten all of it. So you need this kind of whole system through here. So if you just looked at down and decaying wood, because that's sometimes people want to remove it or get rid of it here, whether it's a dead sugar maple on the ground or anything like that. If you like chickadees right now, and if you're ever going for walks along, ponds, streams, marshes, and you see the smaller kind of dead trees on the sides, the chickadees like nesting here, the Carolina wrens like nesting in there. It's really important for these birds. This picture right here are two eastern bluebirds. I took this today at 10 o'clock, just outside the office right through here. But they nest in dead trees or in woodpecker holes. The reason they nest in nest boxes and why this works and why they're making a comeback is because this is pretending to be or acting as if a cavity in a tree. Your chickadees do that, your nuthatches, a lot of birds do this right here, but these just have come back recently on migration with the female on the top and the male on the bottom. When I had to take a break, I went outside, outside to take this. You know, another thing that's active right now, you're gonna have, this is a barred owl, and if you notice, it's in a sugar maple tree. It's a little hard to see, but this is actually in a sugar maple tree right here. These are really active. They're nesting right now. They're sitting on eggs. These are gonna be in Quincy, in many different spots, you know, especially in, you know, tree cavities and cemeteries, they do really well. Right now, for the first time this week, these little frogs have come out as well, and the owls will eat the frogs. You can probably start hearing spring peepers tonight as well. But they're all relying on this kind of forest understory system. And what's really neat about this one, I took this picture 2 years ago now. You can see its little webbed feet right there that I'm circling. That's on a leaf. That's the stem of the leaf right here. And that's a sugar maple leaf that it's on right there and holding on to. So that's the size of like a quarter. And this is where it makes its peeping noise. And that's louder than a rock concert. It's between 90 and 120 decibels. And it's only about this big. And probably doesn't weigh as much as a penny. And you can even see a blood vessel right through there. But that's what you're hearing tonight. You will hear those tonight if you're near any type of wetland and water. And that picture was taken right here in this vernal pool right there. So just to tie into that important role right here. You know, ground cover of leaves, brushes, and ferns. You can see the robins are moving all the leaves around right here because they're getting their insects, their caterpillars, everything else in the leaves. You'll see this right now. The robins are a lot more active doing this because the animals are getting more active. So that's just a little bit of the background of like how important the sugar maples are, because they're one of the co-dominant trees in our region in these forest ecosystems here. Okay. So enough about the overarching thing. So now what's happening with sugar maples? How do we get maple syrup? How do we get maple sap? How is this all happening? Why is it happening kind of this special season between February, March, January? Like, why is this happening? What's going on with that? Okay. So what are sugar maples? You know, so they're essential trees in our like kind of wettish forests. That's like what a mesic forest. They're dominant, co-dominant trees. The soil has to be like well drained, but it's also going to be really moisture rich. You'll see them doing well near wetlands, near streams. They do really well in cultivated areas there as well too. What's really good about them as well too is they don't need all open sun. They can be in sun, they can be in shade. They survive really well in both. And they do really well in forests that aren't really old and aren't really young, but are kind of in the middle, which is really, really important for like lots of other tree species, lots of other shrubs, lots of other wildflowers, and lots of different species of birds. You know, we get the colors from the fall. If you have questions about the fall color or anything like that, I'm happy to talk about that too at the end. So they're incredibly important. All right, so where do we get sugar maples? Okay. So if you look down at the bottom here, I'm drawing the red line. So you're looking at around Tennessee, okay? You know, a little west of the Mississippi right here. Okay, you can see Minnesota, you can see Arkansas. Okay, you can see Illinois, you can see Michigan all right through here, up to southern Canada right through here, Quebec, Ontario through Maine is the main distribution of sugar maples and where maple syrup is being produced. So this picture right here, this is where we can have the most taps, you know, tapping a tree, you know, collecting maple syrup in the country. So you can see Vermont and New York right here. New York has the highest potential for sugar maples. There's also a lot in Michigan and Wisconsin. You know, you can see again down in Missouri right through there. Here's Massachusetts right through here. So that's the potential number of taps, not the actual ones. That's where we're actually getting the maple syrup. So 2 years ago, there were 14 million sugar maples that had taps in it for a little under 4 million gallons of maple sap. Last year, 4.3 million taps, but with 5 million gallons. So you can see, even though it's about the same number of taps, much more productive year last year. So there's a lot of variation in the seasons. Vermont always has the most in the United States. You know, Vermont maple syrup, 2.5 million gallons, New York and Maine are the top 3 producers. Massachusetts is much smaller, and the data from 2020's last isn't great, but there was probably about 60,000 gallons, and then 2 years before that was about 72,000 gallons. So much less, but we still have a nice, albeit small, maple syrup production. Okay, so why does the sap kind of run? Like, what's going on? Why does it happen at these certain times? So what's really neat is there's a lot of, the temperatures are really, really important. And it's very easy to think nights that are below freezing and days that are above freezing. So when you start to get the, in the fall, the leaves in the trees are producing, their main goal is to produce sugar for the tree. The sugars are then used to run the power plants within the cells, so it can produce energy. When the leaves fall off, they're going to store all the remaining sugar as starches in the roots of the tree for the winter. When you start to get to that freezing and thaw cycle, the tree changes and takes those really complex sugars and makes them into that simple sugar, which is sucrose, and it converts that and it starts flowing up and down in the tree. Okay, and these enzymes are triggered when you get that freezing and thawing cycle. So it's basically the starches are stored in the roots, and when you get the freeze-thaw cycle, they release the sugar so they can start moving up and down. Because now, in the next couple of days, the tree's going to want to make leaves, and they're going to need a lot of energy to make those leaves. So they need those sugars that were stored for the entire winter. But to get the sap to run, like you can see in this picture right here, you need nights below freezing and days that are above freezing for it to run. I'm going to talk about this because it's really fascinating how this actually happens. So I want to show you a couple of short videos to help with this. This is from Science Friday on NPR.
Maple tappers wait for the conditions to be just right in order for the tree's sap to begin flowing.
Say you get a freezing night, it creates negative pressure in the tree. The roots will actually bring in more water at that point.
The following day, if the temperature rises above freezing,
Carbon dioxide in there will start to expand. It becomes positive pressure. It goes from sort of drawing up some water to then releasing it. And if you throw a small hole, pressure will be relieved, sap will flow out the tap hole.
and hopefully fill a conveniently placed bucket. Repeat this process throughout your sugar bush, which is neither sugar nor a bush, discussed among yourselves, and you should have gallons of sap.
It's mostly water, it's about 98% water, but it's got some sucrose in it.
So just a little bit of how it's running here, okay? Because they talked about a little bit about negative pressure. Right? What's happening is when you go out in the morning in the wintertime and it's cold, what's in your car windows? The dew or frost, right? Okay, so even if it hadn't snowed or was wet, you still have that frost in the car, okay? So what happens in the sugar maple trees, and I'll go back and forth between these slides, okay? This is from an article from the Globe years ago. When it freezes, when you have that below temperature freezing, there are the main tubes, like we have blood vessels, okay? It's like, or think of like a subway system or a plumbing system in the tree. I can talk about how it's happens in the summer, but water has to go from the ground up to the leaves, okay? And it's a really elegant way that that happens. I'll get into that later. When there's no leaves here, the system doesn't work in the same way. But there's main tubes where the water goes up, it's called xylem. And there's tubes that go down that are called phloem. But within this whole part of the tree, and I'll show you the tap in a second too, there's border cells, there's border areas where frost actually will form in next to the tubes on the outside of it. And it changes the volume and the shape of it. And it actually forces, for free, because the plant's not pumping this up, it forces water up the tree at night. And then as it goes up, it freezes when it's up in the tree, so it locks it in there. And remember, the freeze-thaw cycle triggers those enzymes, so now you've got you have sugary sap. Okay, it's a very small amount, like 2%, and then it comes up there. And then the next day, it's above freezing. So like, you know how like basically January and February was basically 25 degrees at night, 40 degrees during the day the whole time? The sap then falls back down and comes out and goes into the bucket right through here, okay? So at night, the sap is replenished from the roots and goes back up in the tree, which freezes. The ice crystals, like the frost there, cause a pressure change. You don't, in the system, that basically makes the water flow upwards for free for the tree. Like it's not using energy to pump it up. Okay? During the day, they talk about positive pressure there, but that's just melting and it drops back down into the roots. There's a little bit more going on there, but that's pretty much simply kind of as simple as it happens. So if you look at the tree, when you cut it open right through here, you cut it across, you get different layers of the tree. But the water and nutrients and minerals are going to flow just, the only living part of the tree, this is all dead tissue at this point, is going to be right here. It's called cambium. That's the part that's growing out. All right? So here is the way that they tap the tree, right through here. Okay, so here's just an example of the tree. It doesn't go in very far. You can pass this around and see it. And this is where the sap comes in, and it's going to flow down. You saw my daughter earlier. She was drilling up at an angle upwards so the sap can flow down right through here. This is an older tapping system right here. This is the newer, more efficient tapping system that they use. You can see it's smaller, and the bucket's going to hang right on through there. I'll pass these around so you can see that. So the sap actually drops down, collects here, and pools out and goes down. If you want to kind of just pretend you're tapping your own tree. And what I'm handing you is just called the spile. Okay, the technical term is a spile right there. And you're only going about 1.5 inches to 2 inches, 2 inches in there. And so what's happening in the sapwood here, the sap falls down, it's landing in the tap hole and it's coming out. Trees, will have, depending on their size, will either have 1, 2, or 3 taps in there. I'll talk about why that's happening there. Okay. So this picture, this is microscopic photos of these tubing systems. Okay. So I'm going to circle it in red. Okay. So see these larger tubes over here. That's where your water is going to be flowing. Okay, see the tube system right here? That's where the water is flowing. That's where the water is flowing in. See all the smaller openings right through there? You can see it like right in here. That's where the frost happens. So you get the frost and it pushes on the tubes. I mean, it's not exactly like this, but just think of your pulse, change your blood vessel size. And that basically forces water to flow against the force of gravity up and be in the tree. And not many trees do this, but sugar maples do. So then you'll get the sap to flow back down and go into the bucket right there. This is a photo from a couple of years ago, but there's been an innovation in maple syruping here as well too, where we still have the tap hole here with the spile, but instead it's a closed system that's running on tubing, and it's a tubing system. So if you look back to that kind of very dense slide at the beginning, where I just had all the data, you can see there's 10 to 15 gallons of maple syrup being produced, 13 years ago now right here. And I didn't go through the entire, but around 2017, Moose Hill started using the tubing system, which is much more efficient. You lose a lot less sap. It's actually better for the trees too, because the system is much more closed, and that's what the majority of our trees are actually tapped with right there in this tubing system. I'm going to show you a little video about that now too. Yeah. And then once we have the sap at that 2%, I'll talk a little about that, we have to boil it down to 66%, and that's when we get our maple syrup. So let's look at that, like what this evaporator is and what's going on here.
Dr. Abby Vandenberg of the University of Vermont's Proctor Maple Research Center explains.
Simply need to concentrate that sap from 2% sugar, which is how it comes out of the tree, up to syrup density, which is about 67 or 66% sugar. And the traditional way to accomplish that is through heat-driven evaporation.
The sap is run through a series of pans, which not only boil off the water, but provide the syrup's trademark flavor.
Most of the flavor that develops in maple syrup develops as that sap is processed into syrup using heat in the evaporator, things develop like sugar degradation products and Maillard reaction products.
which also provides the syrup with its varying hues of amber and caramel. The final product is filtered, bottled, and sold with old-timey depictions of horses and sleighs and log cabins to give you that syrup.
So if So if I had maple sap with me right now, it would be completely clear. In there, it would have about a 2% sugar solution. This right here is what's going to end up filling up in this area and that area right here. This is a 66% sugar solution through here. And the colors, yeah, it's a little dark, but the colors that you're seeing here, you can think a little bit about caramelization, okay? But there's something else called a Maillard reaction, which you'll get in cooking a lot of times. And amino acids are things that make up our DNA, the building blocks in our body. The amino acids react with the sugar when it gets boiled like that, and that's when you're going to get the color changes through there. The sap sugar concentration can change throughout the season there as well too, because believe it or not, within the tree, there's lots of microbes in there within the system, and they actually break down sucrose into fructose, and it changes throughout the system. And fructose will caramelize in that kind of 210 to 220 degrees, and so you'll actually get color changes from going light to dark, which I'll show you later on, which is somewhat dependent on the microbes breaking down it throughout the season, and later in the season, that's why it gets darker later in the season right through there. And what's really neat here is there's absolutely no high-tech tools that they're using. And this is the sugar maple evaporator that's run on the wood that I showed you earlier. They don't need anything other than a thermometer. So what does water boil at?
212.
Well, right, again, if there's no salt in it, it's right there. Water boils at 212 degrees or 100 degrees Celsius. It's a constant, that's the boiling point. You know, if you had salt water, or if you had salt water, it's going to boil at a slightly different temperature. You ever boil pasta water here. So the maple syrup is going to boil at a different temperature too. And as you start to boil down, remove the water, and so all this steam, you remove the water right here, the concentration of sugar increases and increases. So when you get to 219 degrees in these lower pans here, you don't need to do anything other than remove. So it basically, there's a system of chutes that move through here where you're constantly adding new sap into the system, and it's flowing through basically all these pans, or just think of chutes, until it gets to right here. And when the temperature is 219 degrees right there, you know it's 66% sugar because that's the constant boiling point at that time. And then you remove it, you basically drain it out, and when the temperature drops, you stop draining it and you boil it down some more until you get back to 219. Because then you know you've got your maple syrup. So you can see that in this picture right here, where the little faucet is right there. This is where we have the finished maple syrup. We then boil it and filter it again back in another area, but that's the filtered area, and it keeps constantly running and running until we actually run out of maple syrup. Maple sap there. But you can see again, it can really boil down very quickly. This can get up to over 1,000 degrees relatively quickly through there when it's running. And you're producing lots and lots of water. So the people who volunteer and work in the sugar shack always say how they don't need that moisturizer or anything because they're basically in a sauna for the entire day.
Does it smell pretty good in there?
It smells incredible, yeah. And so if you want to smell it today, tomorrow might be your last day, but they might have stopped today until next season. Yeah. So the maple syrup production, and I just kind of want to talk about this. So like, how old does the tree need to be? How big does it have to be? So typically when you get to about a foot, that's a 40-year-old tree, and that's where it's safe for the tree to kind of tap it through here. And you can kind of see Vin, he's our property, he's the maple syrup manager, along with Jill, who runs our CSA farm right there. But it's got to be about a foot or more to be tapped. So if you plant a sugar maple today, you can probably tap it in about 40 years. When it's around the 40 to 60 year age, between a foot and a half, you probably only have one tap in there. As it gets larger, like you saw those very large sugar maples that were 250 years old, back to the beginning, right here. Again, these can have up to 3 or 4 buckets attached to it, and it's not harming the tree through there.
Did you actually kill the tree in the 2 weeks?
I imagine you could, but you'd have to really overload the tree. You keep it pretty low. So there's certain risks, when you're opening up the system, because if anything gets right here, it's going up and down in the tree if anything goes in there. For example, like the American chestnut tree used to be our dominant hardwood tree. If you went back in the forest 50 or 60 years ago, and the American chestnut it's still, I can talk about the biology of it, but it's still around, but it's much smaller, but it's basically been completely wiped out because a fungus that was introduced from Asia to the chestnuts that are adapted and evolved over there got introduced here, I think, give or take about 100 years ago, and it basically wiped out all the trees. But they don't die. We've got a dozen or 2 dozen at the Wildlife Sanctuary in Canton that are remnants of the older ones. When they get to about 17 to 20 years old, the bark cracks a little bit. When the bark cracks, the fungus can get into the tree and go up and down, and it kills it off. It then regrows from the roots. There are very few chestnuts that get to the point of flowering, producing seeds anymore. So this is open in that same, it's sugar maple, so it's different. So stuff can go up and down, like that's when you get a cut and stuff here. But when it's in the winter time, fungus and bacteria that are bad aren't moving around or growing, and they can't grow within the trees because of the temperature. So that's not a problem. The amount of sap, this would be, people talk about like giving a pint of blood. This might be giving like just a scratch and a cut with how large the tree is. The holes heal up after about 6 to 8 weeks. They'll stop flowing because the tree basically seals itself up because their branches are breaking, stuff's hitting it, they're getting nicked all the time, so they're good at healing it right through there. Like you put like 100 or 200 buckets on it, as an example, the whole way up and the whole way down, you probably kill it pretty quickly over time. So they wouldn't be able to leaf out and produce leaves, but with the way that it's doing, it's pretty easy on the tree. Yeah. So, any other questions? So to make the syrup, okay, that's the evaporator and that's the boiling. It's boiled until 219. That's because that's when the 66% sugar solution boils at. Okay, so that's the right temperature for maple syrup. If you went longer, oh yes.
Does the tree get too old to tap?
No, because if they get too old to tap, they probably have died. So like those 260 to 300-year-old trees, they're producing their syrup production, their sap production really hasn't changed since Moose Hill's been tapping it.
And is there a plan to plant new trees to keep the system going?
Yeah, so commercial sugar mill producers will be planting more trees, and then Mass Audubon and other kind of the organic ones are managing the system both for sugar maples and other trees, so it's a healthy ecosystem there. Kind of like, so it's bird and animal friendly through that. Yeah. So there's a forest management plan both for like commercial sugar maples and then also for educational land conservation type of ones too as well. Okay, and then so if you have a lower concentration, lower temperature, so it's lower, it's more likely to become moldy because the way that system works. And then once you open it, it can potentially mold up there as well too because of the sugar and the bacteria there as well too. And then if you keep boiling it, you're going to make sugar. Like if you've ever had maple sugar. And so if you went back to when I talked about the farm earlier, it was much less likely that they were going to make maple syrup because it was much harder to store and save, and there was very little sugar available in the 1800s, especially outside of Boston, in commercial districts. So they'd actually boil it down until they had sugar, and they would use that sugar throughout the entire year, either to use on their own or to trade. So right now, if we want to look at a sugar maple, probably today up for a week, depending on how warm it is in the area and the sunlight. If you've got just the bud on the end of the tree, with the leaves haven't come out yet, you're good, you're still good to tap. It's not gonna taste different, it's gonna taste the way that you want it to. Once the leaves come out, the whole enzymes, minerals, and nutrients flowing into the sap are gonna completely change, and you're gonna get a much bitter, different, and cloudier tasting, cloudier looking syrup through there. Other things that people are really interested in is also the colors and then the grades. So previously, when you saw grades, it dealt with if it's being sold commercially or to the general public, either grade A and grade B. Now, to kind of, again, increase kind of the commercialization and sales of it, they grade it based on kind of like color now too, where you have golden, amber, dark, and very dark. And this all depends on the concentration of fructose primarily, the types of sugar, where lesser you've got kind of that golden color to amber color, like you can see in the bottle that I brought it here. You know, the sugar, as you get farther along this, you get darker to very darker and much more mapley tasting. And that's just from the Massachusetts maple syrup producers feel that color there. But you can kind of see the differences in colors through there. So just one last video about this too.
For Craig Heaney of the Stone Barn Center for Food and Agriculture, the annual ritual of tapping maple trees to produce syrup gets kind of sappy.
I guess I was 18 years old when I started, and part of the charm for me was collecting 1,200 buckets on snowshoes. I find it really magical because it's just such a great time of year.
With the end of winter, as temperatures begin to rise above freezing, there's an eager anticipation for the first harvest of the year.
If you've gone through a long winter, it's just like, all right, there's hope, you know, it's like, and it's going to taste pretty damn sweet at the end, you know.
Maple tappers wait for the conditions to be just right in order for the tree's sap to begin flowing.
Say you get a freezing night, it creates negative pressure on the tree.
So I just
It
wanted to
looks
say,
a lot.
yeah, I just wanted to get through the first part, like through there. With the whole kind of commercial system as well too. So they're moving away from those buckets and moving into the taps. And I'm going to talk a little bit about the bird filling and tie everything together with maple syrup production there, but I was just wondering if there are any general questions that you'd like me to answer before I talk about before I bring it back to the ecological effects too. Yes.
Yeah, so syrup produced in Michigan or say New York or Vermont, is there a distinct difference in taste
You're not
for the same grade of?
You really don't get like regional differences
Yeah.
in maple syrup, and if it is, it's gonna. I would suspect it's gonna be really subtle. You could have local differences in the same potential grove again, because what you'll get mostly is you'll get differences in sugar concentrations among the different trees, and I've not heard of, say, like the bacterial composition of certain trees, you know, like breaking down the sap in there, causing a much difference in taste.
And is maple syrup production in Europe also? They have
No, so you can also, one thing that I didn't fail to mention is, in Europe, there's no sugar maple trees. Like they don't exist over there. But they do tap, you can tap other trees. People can tap walnuts. Black walnut is one. Also birches, for example. If you did birch syrup, it tastes more like root beer. So you've got like a root beer syrup because there's sugar concentration. You can also tap other maple trees, like the red maple that I showed you. You can tap those, but the sugar concentration range is anywhere between 0.5% to 1.5%, so it's lower, so it's not as sweet. Even like the Norway maples, but that's only like 0.25% of sap. So you're collecting a lot more sap from much lower sugar concentration. Because you typically will need about 40 to 50 gallons of maple sap to get 1 gallon of syrup. Whereas if you did like a red maple or Norway maple, you might need 100 gallons or 150.
Is there any birch production in this area?
There's no birch production in this area that I know, but I do know kind of also like with micro distilleries and other like artisanal things, I'm seeing more and more of like birch syrup, hickory that are coming up at say I don't know, fancy food food markets and stuff like that, yes. But like, you know, where I'm at the Museum of American Bird Art, one of the artists there, just an example, Jim Coe, he has like 20 sugar maple trees at his house, and he boils about 2 to 3 gallons of sap every, about 100 gallons, 200 gallons of sap for about 3 or 4 gallons of maple syrup every year. So people do this with just their own trees as well too. So then just to tie everything a little bit back together with bird-friendly maple syrup, and I'll talk a little bit about climate change through here. Mass Audubon is the organization in Massachusetts that can look at commercial and other types of maple syrup production and decide whether or not that it's like bird-friendly, and it kind of ties back into what I talked about earlier. So here's a barred owl in a sugar maple. This lives in over at the Wildlife Sanctuary in Camden. All the migratory birds that are coming back, you know, really benefit on these hardwood forests that are in New England. And then just to kind of tie everything back in together, you know, the diversity, where it's not all sugar maples, it's not all one tree, but the diversity of older trees, whether they're sugar maples, oaks, hickories, the understory, blueberries, you know, the smaller trees, the shrubs, the ferns are incredibly important, you know, for the ecosystem. So if we look back again at, you know, these foundationals from the down logs, the dominant trees, the ground cover, you can manage, and we do this at Moose Hill, we do this at Drumlin Farm, we do this at Ipswich River Orchard up in the Wildlife Sanctuary up in Topsfield and Ipswich there. You can really manage both for really good quality maple syrup production, but also really being incredible habitat for migratory birds, resident birds, and other animals there. So, you know, that's like managing both the forest, you know, for sugar maple operations, but also managing it for wildlife, including birds. So, you know, just to review, like, you know, that's the diversity of tree species. That's layers of vegetation with different heights and ages through there. You know, the cavities, so bluebirds or tree swallows can nest. You know, providing lots of food cover and shelter. So you can have birds like orioles that are nesting there, which will be migrating back in about a month. You have these beautiful birds, and if you walk around in Quincy in like a pine forest area, this bird will probably be singing you even if you've never seen it. This is an ovenbird that nests on the ground there. That scarlet birds like scarlet tanager that nest. This nests in Canton. It's really important for barred owls and great horned owls. You know, all the different woodpecker species. This woodpecker is actually at a sugar maple that's weeping sap where it had a cut on the tree, and it's coming over and actually drinking the sap right there. You know, larger birds like pileated woodpeckers. You know, it's really important for that type of habitat. So one other thing too is climate change could potentially have a really strong impact on our sugar maple trees and syrup production. You know, just to briefly, in the past 100 years, we've got about 3 degrees of temperature rising. The growing season has expanded by about 2 weeks. You have sea level rises, and then highlighting stronger storms, and also the growing season. I really want to talk about the changes in the growing season, because that's really, really important, especially for sugar maples. So you've got a lot more extreme weather. Here's Boston Harbor right here over by the aquarium with one of the nor'easters where it's flooding right through there. But the one thing that I really want to talk about here is the variability of the systems now. So, you know, with the rains, the variable rains, where it might not rain as much, but then all of a sudden really, you know, huge pulses of rain. This winter is a perfect example of an increased variability in temperature in the seasons here. You know, a few years ago, this is in Norwood, where basically a strong rainstorm on a summer afternoon flooded out the downtown Norwood here and shut down the emergency room, which is still closed, and they basically knocking it down at the moment right through here. So variability there. Farmers, this is Flint Farm in Mansfield. This is also from Attleboro. You know, it's New England. The weather's always erratic here, but you know, especially with farmers, the warm weather and then cold, the warm and cold, and instead of it being like variable like this, it's variable like this now, can be a huge problem. So that's where I want to tie in with the maple syrup production. So this is the kind of the sweet spot. So this is temperature, this is kind of like spring, this is the sweet spot. The sap season is when it's above and below freezing. Okay, above and below freezing right here. And what's happening, and you've seen this really well this year, okay, is the system, oops, sorry. It's moving. And this also, if this graph was a little bit better, it's moving to more like this. I think of the day when it was like, I don't know, about 50 or 60 degrees back, either in January or February. And then the weekend after that, it was minus 10. And then it was back up to 60 right through there. And so one thing that sugar maples really need, because they do well in the cold, what they really need is, this might not look familiar to people, this is what we call snow. Okay? It's white. But they need actually snow cover because they need their roots to be covered. So if you got that negative 10-degree day, not a big deal for the sugar maples. But if you get a negative 10-degree day and the roots aren't protected, the blanket's not there anymore. So when the roots are typically staying between 20 and 30 degrees, now they're going down to negative 10. The sugars and the water that's stored down there that normally doesn't freeze and frost over, freezes and frost over it. So now you've got an incredibly stressed tree that might end up causing the death of it later on, getting through the years. But again, the sugars are going to be different. Our sugar concentration has been wildly erratic this year in some of the, in overall, from 3% down to 1%, which is potential variability, because we really need like that strong snow cover right through there. So with the rising temperatures too, okay, you can see that just overall, sugar maples do need those cold winters with snow cover. So what the climate models are suggesting is that our sugar maples are going to shift north. So that doesn't mean like the trees that we have here now, but over time they're going to shift because the seeds, the seedling sugar maples, there's not going to be as many seeds because of the stress, okay? And then oaks and hickories and other trees are going to be, which are more successful in this environment down here, are going to be able to produce more seeds and they're going to be able to grow quicker, so they're going to start to outcompete the sugar maple. So you're going to see that shifting north over a very long period of time is a potential for that to happen. But what I really want to highlight again is this quick temperature swings, okay? That can be add a lot of stress, and it can, to the trees, and then it can affect not only this maple syrup production, but it can affect bud bursting out, early leaf production, the strength of the leaves, and it can then make the trees more susceptible to disease because they don't have the sugars that they used to have to then produce immune responses. So you've got like kind of the drought and variability there. It can change the soil acidity and nutrients because you don't have that snow layer there protecting the soil anymore. So you get effects on growth of the tree, its ability to fight off disease, fight off insects, its ability for the next generation of sugar maples to survive. Okay. And then I want to talk a little bit about insects, okay? And I want to go back to this again, the picture of, the diverse, woodland like right here, that I showed you earlier, and insects and managing it for this. So here is a sugar maple grove down in Missouri, right through here. So you can see the buckets down right here. It's just sugar maples and there's no understory. So it's low diversity and a monoculture. This goes back to the diversity of trees right here. What can happen right here is you can have a outbreak of disease or of insects right through here that could decimate an area because there's not a lot going on here. There's not a lot of variability or diversity in the system. So kind of like how they have to use pesticides on corn and lots of crops. When it's a monoculture, the trees aren't as resilient and they're much more prone to insect outbreak through here. Whereas if you have a diverse ecosystem and you manage it this way, you're going to have many more insects in this system, way more. You're going to probably have more pathogens and disease here as well, too. But what's happening in this system, there's many more insects, but there's also more wasps, there's more birds, there's a greater number of trees and shrubs, so there's different insects eating different trees and shrubs. So the system is a lot more stable. So if you get a you can start to get more climate variability here. If you have a system that has more stability in it, it's better able to withstand that variability through here. And then you're gonna even have happier birds, mammals, owls, all that type of stuff through there. So that's kind of like, the effect of potentially climate there. But then, with that, like, I just want to give you like the view of the ecosystem, the really nice stuff with the maple sap production and everything like that, and I'm more than happy to take any questions. Yes?
What do they do after the taps come out? Does they leave a hole in the tree or?
Yeah, so I don't think I have a picture of it close up. So what will happen is just like when a branch breaks off on a tree, it'll scar up, So, but if you ever want to come to Moose Hill and go for a walk, I'm more than happy to show you around. We can look at the tree and you'll see a little circle that's kind of scarred over, like a tree scar. So it stays there. And like this year, the taps would have scarred over on some of the trees. We would have had to retap the tree because at 6, 8 weeks, 4 weeks, depending on whatever, like the individual tree, it will start to heal up because again, when the tree it's open to the outside environment, it wants to close that up as quickly as it can. It's just a lot slower in the winter time because the tree's not that active. Yeah. Yes?
Yeah, any thoughts as to the container that the maple syrup was held in?
Like
In
it
the
was
stores, you see
like
the
plastic,
jug,
yeah.
glass or metal. Any thoughts on that? I sort of like the glass ones, which is.
Yeah, I like the glass ones. I mean, my kids go through a ton of maple syrup, and the one at Trader Joe's that's the most affordable is plastic, and so I don't really know the difference, but glass is getting more stable. With the glass and the sun getting through there and stuff, you could have some degradation because of the sun, same like with how with olive oil they have dark glass on like that. So, and the larger containers are almost always metal, like the Vermont ones there as well too. And then, so like also when you're looking at maple syrup, this was in the presentation stuff too, you want to make sure it's, it's talking about like, if it's Vermont made, make sure it's MADE and not MAID. Because like, there's certain things they can get away with, like if it's, because a lot of all the cheaper ones, it's all high fructose corn syrup with caramel color and added sugars in here. Whereas so like this, it's pure. It's just sugar water from the tree itself. There's no additives, unless it's got both. And you can look at some of the more inexpensive maple syrups that are actually maple syrup will be a lower sugar concentration, so it'll mold up quicker. And sometimes they do have some additives in there, like additional sugar. But they can if it says like Vermont made, like MADE comes from Vermont, stuff like that. That's pretty regulated.
Where do they sell the moose, the sanctuary?
They sell it at Moose Hill in Sharon,
Yes.
and they probably have some, but it does sell out at Trailside over in Milton. So right there. So so they'll have it at both. And right now, I think ballpark, we were able to basically fill 800 or 900 bottles, I think, so far. And we probably sold about half. It's mostly in the 8-ounce size right here, but we also do sell like growlers in a liter. This I think is $13 or so, but you can see all the, why it's more expensive. All going into in a liter is about 40. Members, I think there's like a discount, and then there's a small like maple leaf ball that's 3 ounces that is probably good for a couple of pancakes.
Yeah.
Yeah,
So
but
they don't sell-
you should be able to get it at Trailside, so about 20 minutes, 15 minutes away, unless it's sold out by now. Yeah. But we, like I said, best season ever at 100 gallons, so, yeah. Yes?
Okay, is there a history of how they discovered maple trees have sap and then how they figured out 219 degrees exactly? I mean, somebody had to spend a lot of time figuring this out.
Yeah, so First Nations and Native Americans, there's no oral or written records in this specific part of the state. In Western Massachusetts and New York West, there are. It's likely that they would have seen, I'm just gonna go back to a picture. Stuff like this with the animals coming to it and it weeping sap, and then notching the trees to have the sap running out and collecting it that way and boiling it down into sugar. And then that knowledge being passed on to colonial Americans through there. And then the colonial Americans were almost never boiling it down into syrup. They would have been boiling it down and sugaring it. So boiling it down and then doing the sugaring process to have shelf-stable sugar, because this isn't shelf-stable through there. And then the 219 degrees was probably just, I don't know. So I don't want to be speculating, so I won't. Yeah.
Trial and error.
Yeah, for trial and error. But and also too, just I wish I could get this picture again. You know, the Museum of American Bird Art is over in Canton, and you know, I took this picture today while I was sitting right outside my building. These are really active. I've seen owls. All these pictures are mine that I've taken of the animals too. So. So these are out, about 250 are in the vernal pool today. They'll probably be there for another couple of days. Tonight there might be hundreds of salamanders moving in because it's wet. But this is the only time of year you'll hear this. So they sound like quacking ducks. I don't know if did I play the video? I think I skipped over it. This is from last year on March 18th. I've got another one from today, it's just not as dramatic, where there's about 500 frogs, and all those ripples are individual frogs. And this was the first time there's a lot of frogs in the water that I've seen in years past. This was the first time I'd ever seen it like biblical proportions, where they're falling out of the leaves and moving in, because these little frogs are kind of neat. So these are neat too, but this is a wood frog. You can see it in the snow. This frog goes about this far below the soil. So it freezes solid in the winter. Like heart stops, freezes solid. It fills its whole body up with sugar in its liver and its muscles. So if you know when you freeze a Pepsi can, it's like kind of like a weird. So basically, its cells bend and don't break. So they never, because if the cell broke, it would die. So it could freeze solid. Its heart could stop beating. It could stop breathing for weeks to months. And then right when it thaws, this was that not 80-degree day when it was like freezing last year, and then all of a sudden it was like 70 to 80 degrees. They all come out and go to the vernal pools to set up mating territories and mate and lay eggs in the ponds. Because throughout the entire rest of the year, you might see them occasionally if you're around, but they're all in the woods, just kind of hiding under wet logs and eating whatever insects might be around. But for like a week or so, they're everywhere. But only if you go walking through. So if you're walking in the woods and you hear like quacking ducks like that, it's going to be all these little frogs in the water. And then at night, the spring peepers are out. And they're out during the day too, but you really hear them at night. But this is just a wonderful time. But if you came, we've got 1.5 miles of trails, and everything is just, again, it's nature. You never know what you're going to get when you're there. Everything has just come alive in the past couple of days. We had 5 red-shouldered hawks flighting overhead, 3 red-tailed hawks. The red-shouldered hawk was harassing a great horned owl that was moving around. So it's just been really active. Deer. The turkeys may run after you, though. First time ever we've had a bit more, but they're only mad at the cars, they're not mad at the people. Turkeys are weird. Anyway, sorry, I was just saying, if you want to go for a nice walk, it's really nice there. Yeah.
That's great.
Any other questions though? Yeah, well, we do lots of programs, you know, like at libraries like this, but we do nature walks, we do lots of art programs with, you know, kids and adults. We have a lot of summer camps, a lot of school programs and everything too. So if you're in, yes.
Any thoughts on why there's so many rabbits around?
Yeah, because there's just lots of food for them, and there's just not as many things eating them. You know, so like lawns are great, you know, because they're just great for rabbits, you know, because things like, you know, and there's coyotes and foxes around too, but there's just not as many. It seems like, for some people, it probably seems like there's too many anyway. But, you know, you give a rabbit a lawn and a couple of shrubs, and then you've got 10 rabbits, you know. And, you know, like the owl yesterday, I saw it carrying a rabbit to its nest, yeah. But it's just, and then, so there's just, yeah, that's just what they do. Yeah. Yeah. And they love grass, just kind of like geese. Yeah.
Too many geese, too many turkeys.
Yeah.
Yeah. Too many coyotes too.
Yeah, but well, thank you very much for your kind attention. I really appreciate it. I'll be around.